first time with him. Even the fifth edition was basically one that I had responsibility for because he was ill.
And we had a lot of skeptics at first. You know, we were doing these studies on individual F2 plants, which we would grow in the lab, remove the coleoptile, and that's what we used for our isozyme analysis. And then we would transplant these, plant them out into the field. And actually, that transplanting process gave us very uniform plantings. And I remember people like John Dudley, for example, was very skeptical earlier on. You can't get good data from single plants. But he became one of the strongest proponents of the marker approach marker. So they approach later on, you know. So, but you know,
I used to come home from college all excited about some new piece of information I just learned, and I'd start to tell him, and I he already knew all about it, so he was ahead of me always. But he had grown up on the farm that I still own now, and we just shared a passion for the outdoors and agriculture in general. And that's a lot of my interest started from this topic.
Well, there's no question but what the book is number one. I remember going. I was among the first American agricultural scientists who visited China, and I would go into the library and ask them to let me see the library. And I would go look and see, and there I saw copies of Lion, Buckman, and Brady, and a few Bradys, but they were there. And as I've gone around the world, I'm introduced to people and so and so from the International Rice Research Institute, or from Cornell University, or from U.S. Agency for International Development, and pretty soon now, Brady. Oh, you're the Brady?
The Brady?
Nature and Property of the Soil. Don't you? Oh, how are you? So the book is much has been recognized much more than anything else that I've ever done.
Well, they had 4 jobs, but they had the possibility only to hire 3 people. They were the plant pathologist, a microclimatologist, a weed person, and a plant physiologist. So they hired the plant pathologist, the weed person, and then I had to fill both the microclimatology and the plant physiology position. So for the first time, I was forced to learn about microclimatology. I'd had Chandler's class back at the University of Wisconsin, but other than that, I knew nothing about microclimatology. So I really worked hard and studied, and I now am a fellow of the Royal Society of England in the microclimatology.
Well, to get a sample of what that cow ate, you need to take it from the animal, because we really don't do a good job of guessing what that animal's eating. If you go out and take a sample of pasture, it doesn't represent very well what the animal actually picks and chooses to consume. And so when the animals were dead, then I was able to open up the room and take a sample of the lumen contents. And that's where we saw that these animals were indeed loaded with aluminum, literally.
Did you wear a clothespin when you did this?
No, but you tend to pay attention to which way the wind is blowing, so the wind's in your face. But we actually did dig one up once. The farmer had already buried it. But I needed the samples, and so we dug it up.
What drive you is getting the aha moments. But another time that we got an aha moment was when we were looking at seedling emergence and looking at the pattern of seedling emergence. And we're able to mathematically express that and to find that seedling emergence pattern was maintained throughout the life of the crop. You have your early emergers have a few more leaves, not a few more, but a little bit more leaf area than your late emergers, and that the pattern of leaf emergence, of seedling emergence, then shows up in the pattern that you have of leaf number throughout the crop. It's simple, We ought to think that, but we didn't.
I mean, I remember taking my wife and 2 kids who were pretty young to New Zealand, and we spent a month on the road going. But it would have been easy to say, no, the kids are in school, I can't take them. But if you look for an excuse, you can find it. If you look for a way to do it, you can find that too. And I remember taking our kids to Indonesia, and they just dropped out of school. Well, we took their books with them, but their learning was not in the books. It was in learning the culture and making batiks and all of this kind of stuff, which stays with them the rest of their lives.
Well, I have a philosophy which I carried over when I went into administration, that everybody in the team is important, even if they're the typist typing up the manuscript, instead of the person having the original idea. The old days of the Herr Doctor Professor were gone by the time I came along. And when you get into teamwork, you realize that you can do so much more if you use everyone's strengths and work together on things.
So my reaction to young people is, do whatever you can, get as broad experience as you can, go overseas, learn internationally. I spent a year sabbatical in New Zealand in 1970-71. Changed your life. And, you just are much better as a result of doing those things. So I've been very fortunate.
And I can sit at my desk and I look at my data and do my experiments, work with my students, and that's what's so exciting, to find out new things, new knowledge. That's the exciting thing of being in science.
And it takes a team, it takes a long-term effort, and it takes a very big commitment on the part of everybody to make that happen. When it does, we can make extraordinary progress. And it's the only way we're going to find answers to some of the major issues that we're dealing with.
Young people do, willing to step out and take a chance. The worst thing that the person can do is to seek security when they need opportunity. And I can only imagine what might have happened if I had said no when I had the opportunity to go to South America. But it was a totally life-changing event for me, and I could never replace it with any planned event that would equal it.
And the saying, why do I persevere? Why do I go on? It's because of the fun of science.